Okay, so just to finish up here on the electroscope. So when we bring a negatively charged rod in close but don't touch, then all the electrons in the electroscope run away from it because negatives repel. And so they run as far away as they can get, which is down into the leaves in this electroscope. And the leaves being these really thin foil spread apart from each other because they repel each other because they're both negatively charged. And because all the electrons in the electroscope ran down into the leaves, it leaves a positive charge on the ball of the electroscope. Okay, but as soon as I take the rod, the negatively charged rod away, the electrons are like, phew, it's gone. And they just spread back out and the whole electroscope becomes neutral again, and the leaves fall back together. So there's no transfer of charge here. And when there's no transfer of charge, this is called charging by conduction. Okay? Or excuse me, charging by, I'm writing the word in and I'm saying charging by induction. We're inducing a charge by rearranging where the charges are in the overall object. So it's charging by induction. So now I'm going to bring a negatively charged rod in and I'm going to touch my neutral electroscope. And so the electroscope is neutral and the rod is negative, and we know that when there's two objects with different charges, then electrons will be shared. So the electrons from the rod come over into the electroscope and they spread out all over the electroscope, including down into the leaves, where the leaves will spread apart. And because they'll both be negatively charged. But the ball of the electroscope will also be negatively charged because the overall charge on the electroscope is now negative. When I take the rod away, the electroscope stays negatively charged and the leaves stay separated. And they will stay separated until an object comes and touches the electroscope and removes the excess charge. And when I do that, that's called grounding, right? It's kind of like when those old televisions or old computer screens, when you would touch the screen and you could hear the static electricity. What you were really doing was you were removing that buildup of charge that was on it. You were grounding it. It's also the third prong in the plugs in your house, right? Those two prongs, and then there's a circular one. This is the ground that carries away the excess buildup of electric charge, so that there's not a lot of static. Okay, so this will stay, then it will stay charged, the leaves will stay apart until we ground it. This is called charging by conduction, when you actually touch the objects together and there's an actual transfer of charge. Okay, so that's if I bring a negatively charged rod in. What if I were to bring in a positively charged rod? So I have my neutral electroscope again, with the ball and with the shaft down the center and the leaves. And now this time I'm going to bring close but not touch a positively charged rod. What's going to happen now? Well, remember all the little electrons in that sea of free electrons that ran away from the negatively charged rod. They're going to run towards the positively charged one. They're going to be like, oh, look, there's a positive rod up there. And they're all going to run up like little kids to a candy truck. So they're all going to run up to the ball of the electroscope. So there'll be a negative charge up here, but it will leave behind on both leaves a positive charge, and they will spread apart. So it's going to look exactly like what it looked like when we brought the negative rod in. There is no actual way to tell if the rod that we brought in is positive or negative, because the leaves are going to spread apart exactly the same way. And when I take the rod away, they're going to fall back together. Okay, so it's going to look exactly the same, but on a microscopic level, we'll know the electrons are moving up, leaving a positive charge on the leaves. Remember, there'll be no such thing as the positive charge is running away. The positive charge is stuck inside the nucleus. It can't move. It's the sea of free electrons that move. Okay, and again, we haven't touched, so this is also charging by induction. Okay, and then the last one, I'm going to bring that positive charge rod in and I'm going to touch it to the electroscope. Okay, so it's a neutral electroscope, and this time I touch it with a positively charged rod. What happens? The electrons from the electroscope go over, because now this rod is missing electrons, and so even though the electroscope is neutral, it will share some of its electrons with the rod, leaving behind on the electroscope a positive charge. Both leaves will be positively charged. They will spread apart. When we take the rod away, they will stay apart until something comes along again to ground it. This is also charging by conduction. Okay, so when you don't touch but you induce a charge by making the electrons move to one area of the object or another, it's called charging by induction. But when you actually touch and there's a transfer of electrons either into the object or out of the object, that's called charging by conduction. Okay, and the electroscope shows both of them. All right.